Oh.
All right, so that's not what I want to show you guys. I want to show you guys this. Today I want to go through two special functions. We won't learn anything new in terms of calculus. All the calculus stuff you've done still applies here in terms of finding inflection points and finding turning points. But there are two functions that are used in modeling in everyday life that are specifically mentioned in the course outlines and are regularly examined in SATs and exams. Hint. So these two functions are called logistic and surge functions. So the top here. We'll go through them one by one, surge first and then logistic, and hopefully you'll be able to see how powerful they are. You may have stumbled across them in the textbook before. They do appear in a couple of the questions, but I thought it's worth spending some time going over them today before we do some more practice and before I release you on general practice, I guess. All right, first is surge. How much of this can you guys see? Most of it. All right. This is a surge function. A surge function is normally a function of time. So you can see here I've got it written as f of t. T here is essentially x. It's the x axis. Normally it's modeled as time goes by. A and B are both positive constants. So they can be decimals, fractions, whatever, but they're constants. And then t e to the minus bt. So e recognized, we've come across e before, and t is the variable. When you plug an equation of this form into a graph, you get the shape to the right. And what this shape is used for is modeling, especially drugs in your body. So when your body ingests drugs, in this particular case, nicotine, it's assumed that it happens all in one go. So you might notice how at time 0, there is 0 nicotine, and then it shoots up incredibly quickly. The assumption is that the cigarette, vape, whatever, is ingested very fast. And as soon as you breathe in, for example, this graph here is the model of one cigarette. As soon as you start breathing in, your body does two things simultaneously. Firstly, it starts working to absorb the nicotine. So into your lungs, it gets absorbed into your body. And this is true for all drugs. If we swallow or drink them, as soon as you do that, your body starts working to absorb them. So what's happening here is right at the start, it goes up incredibly steeply. Your body absorbs it fast. However, at the same time as your body absorbing it, your body also starts breaking it down. So normally the kidneys are responsible for cleaning your blood. They will clean the drug out of your system. And what will happen is that cleaning starts around here, and then your body runs out of drug to absorb. You're not absorbing anymore, and then your body goes through the process of cleaning. Now, cleaning happens quite slowly and can take quite a long time. So you can see here that if you have a cigarette, within 10 minutes, your body has fully absorbed the nicotine. However, for your body to break it down, it takes nearly an hour and a half. What you might notice is the function technically asymptotes to 0. The math model we use doesn't work perfectly. Clearly, your body will break down all the nicotine eventually. However, our maths model says it will never reach 0. Note that it's not perfect. There are two quite important features of this that I would expect you guys to have notes on. Firstly, there's a turning point at x equals 1 on b. So in our particular case with the nicotine, you can see that the constant in the b is minus 5.36, therefore b is 5.36. If you imagine 1 over 5.36, 1 over 5.36 is like 1 divided by 5-ish, about 0.2. That's where this maximum occurs. That is 1 on b. So you guys would need to be able to do two things. Firstly, in theory, I can ask you to take this, differentiate it using product rule, factorize it, and solve for when it's equal to 0. But it's much quicker in your notes if you know that the first derivative will equal 0 at 1 on b. The second derivative will equal 0 at x equals 0 and x equals 2 on b. X equals 0 is here. That's our first point of inflection, which is where the graph is the steepest. So it's going from concave up, concave down there. That is the steepest portion. It's not immediately obvious on the graph. The reason that's kind of makes sense and why it's exceptionally good for us to model drug uptake is because this steepness of this curve models how quickly your body is absorbing the drugs. And when you first take the drugs, your body has a whole bunch of drug inside it and no breaking it down yet. Because there's
Mr. Gutenberg.
Hello.
I got a small issue. I can't see anything right now, like from my screen.
Oh, does anybody else have that issue?
Like, I feel like my Zoom is like lagging.
Others, sing out. Can you see what's on the screen?
Yes.
Yes.
Yeah. Yes.
Yeah.
Ivan, you might need to quit Zoom, find the link again, rejoin us.
Oh,
I need to
gosh.
just get good, you know.
Sorry. We are recording, so you'll be able to catch up what you missed. I hope you come back soon. What was I saying? All right, this first inflection point is where the uptake of the drug is the steepest because you have the most of it in your body and your body's not yet breaking any down. The second inflection point is 2 on B. Note the relationship between 1 on B and 2 on B. Basically, if 1 on B is there, 2 on B will be twice as far out. So if that was about 0.2, at about 0.4, or about there maybe, there is a second inflection point. And that's where we're going from concave down to concave up. And it basically indicates your body is like, well, breaking down, but because there's not a lot of drug left in the system, that breakdown is going to happen slower and slower. There is an example or two of this in the book, and I'll give you some more examples as practice. But essentially, it's a special sort of formula that's used for modeling drugs.
Did I miss anything? Did I miss anything?
No, we just waited for you to repeat.
Okay, can you repeat everything again?
He waited for you, mate. You haven't missed anything.
No, I don't care.
I'll just show you a couple of other examples of surge functions. I've been on the internet and looked up different surge function modeling for drugs. This one's alcohol. So they blocked out part of the graph because they didn't have good data here. I don't know why they did it on the top, but they gave people 2 drinks. It's assumed that they had the drinks instantaneously, so shots, for example. The uptake was pretty quick. And then the interesting about alcohol is your body takes a fair while to wear it down. Like a considerable length of minutes, that is like 2 hours 40. And that's just from 2 drinks, and you're still feeling some. Bear in mind that later on I might show you a problem of it's quite possible to drink a fair bit, go to sleep, and your body still won't have broken it down, so you're under the legal limit. Okay. Lastly, to show you just how uniformly this modeling is used for drugs, there is this one, which is real data. Well, it's not perfectly smooth, but I just found it amusing. Second data set or second function type is logistic functions. So, logistic functions come in this form here. Again, they're a function of time, ft, equals c over 1 plus a e to the minus bt. That's the general form of a logistic function. What it models, rather, is population growth or the spread of something through a population. The most traditional example is either spread of a rumor through a population or spread of a virus through a population. We'll come to that in a sec. The letter on top, C, is called the carrying capacity, which is the maximum number a population can take. So carrying capacity might be a number of different things. Carrying capacity could be if you're looking at an island that has enough resources and grass and water on it for 1,000 squirrels. The carrying capacity could be 1,000.
So is it like a maximum? Oh, yeah.
Yeah, it's a maximum. So on the left-hand side here, you can see an exponential function. And in the early periods of time, exponential and logistic look pretty similar. They behave similarly. So imagine if you put 2 rabbits on an island, they would breed fairly quickly, they would grow very quickly. However, a logistic function is particularly good because it's far more realistic. You know that if you put 2 rabbits on an island, that it won't continue in exponential growth forever. At some point, the rabbits are going to start running out of food. They'll start competing with each other for resources. It will level off to sort of a natural level of a population that the island can sustain. And that's where the logistic curve is great. If you put this function into a calculator, you can see a logistic curve that curves up steeply initially, but at about the halfway point here, we start flattening off. And that flattening off indicates we're running out of resources. In the rabbit's case. To give you a different example, let's pretend there is a really juicy rumor in year 12, and there is, for the sake of this graph, let me see, 80 of you in year 12.
What's the rumor about?
Does it matter? Just think it, anyway, it doesn't matter. No, there's a rumor. And at the start, the assumption is maybe 1 or 2 people know. Now, 1 or 2 people can blab a little, but even if they tell, say, 4 friends, after the first day or so, if they tell 4 friends each, we're only at like 8 or 10. So, okay, 8 or 10 people know. What happens next is that those 8 or 10 people will tell another 4 friends each. And it goes up very quickly. However, at this point here, which is, as you note, the inflection point, given by this in your notes, what will be in your notes soon. At the inflection point, if I'm spreading a rumor and I go, hey, have you heard this? There's actually a 50% chance that the person I'm talking to has already heard it, which is why the growth slows. At this point here, almost everyone's heard the rumor, so it's not going to grow much more quickly. It starts leveling off until eventually everyone has heard it.
So it's like more realistic.
Yeah, it's far more realistic in terms of modeling growth of, say, a rumor through a population or a population in limited resources than an exponential function is. And I thought I'd go through a sort of, I wish it was a made-up example, but a semi-made-up example. Do you want me to stay on the screen a while longer? I can see some people still taking notes. Or should I just scroll on? I will post this recording in the video section after. But the important thing to notice is that there is no turning point here. In theory, the graph keeps increasing forever, but it's increasing towards that asymptote, so it certainly flattens off. At the first half, it increases very fast. So it is increasing at an increasing rate. Increasing an increasing rate means the second derivative is positive. Then it increases, but at a decreasing rate. So here, the second derivative would be negative. And in this portion here, the second derivative is positive. So let's consider this example. Our fun example for the day. Let's say St. John's has approximately 1,200 people in it. You know, students and staff all put together. And let's introduce a mystery virus. On day 0, 4 people have this virus. Sorry if this is slightly triggering for anyone. On day 3, 3 people have the virus. And our question is, well, what's day 7 going to look like? And we're going to make a few assumptions. Firstly, we're assuming no behavioral changes. So the growth rate stays the same. Assume no immunity. And assume everyone can only catch it once. So this is essentially a rumor. No behavior. People are spreading the rumor. No one's immune to the rumor. Once you've heard it, you are assumed to then hear it and keep spreading it, and that you can only hear the rumor once. Same true for a virus. All right, so let's work out. We've got 2 bits of information here, and they're going to help us find C and A. Sorry, B and A. C, we already know, is the carrying capacity. The maximum number of people who can catch the virus, hear the rumor, is 1,200. So far, our logistic function looks like ft equals 1200 over 1 plus ae to the minus bt.
Why a equal to 4?
Pardon?
Is a equal to 4?
No, a is not equal to 4. We'll
Wait.
find a in a sec.
Or what is b?
Don't know. We're gonna have to find out.
Okay.
These pieces of information here highlighted in green are effectively points on the graph. This point is time equals 0, population is 4. And this point is time equals day 3, population in fact equals 30. So they are hidden, I guess, points on the graph. And anytime you have a 0 on a graph, it's actually going to work out really nicely. What this first point is telling us is that initially, well, 4 people had the virus. So at time equals 0, the f of t is 4. So 4 equals 1200 over 1 plus ae to the minus b lots of 0. Now, e to the minus b lots of 0 is just e to the 0, which is just 1. So that's going to be 1200 over 1 plus a. So we've got this equation 4 equals 1200 over 1 plus a. Can anyone sort of look at that and see what a would be?
Would it be 299?
Nice, Jamie. So what Jamie's saying is that 1200 divided by 300 gets you the 4. In order for the bottom to be 300, a must be 299. So we've got a. Alternatively, you can multiply this up here, divide the 4 down, and it will work out to be a 299. But sometimes we can just sort of see an answer before we have to get all the algebra out. All right, so let's use the other piece of information. We're trying to use the 330 piece, and now we're hunting for B. So what that is saying is that the number of people with the virus is 30 when day is number 3. So 1200 over 1 plus 299 e to the minus b dot
Would
3.
not believe Sam, I died in the exact same spot you died.
Pardon?
How is the dude? I had a full inventory of black.
What happened?
You lost your diamond sword.
I'm pretty sure that Luke was trying to unmute and talk to someone else, but shared his gaming thoughts with us.
Okay, it's good. Minecraft is good. I love Minecraft so much. It's one of the best game ever.
Lovely to see you're making the most of this valuable time, Luke. All right, let's try solve for B. If I was solving for B, I'd multiply the entire denominator up. 30 bracket 1 plus 299e to the minus 3b equals 1200. Now, at this point, some people are going to be tempted to distribute into the brackets. I would divide both sides by 30. 1 plus 299e to the minus 3b equals 40, because we're dividing by 30. So there's a divide 30 here and divide 30 here. Then what's going to happen is we take 1 from both sides. 299e to the minus 3b equals 39. Divide both sides by 299. E to the minus 3b equals 39 over 299. The numbers aren't necessarily going to be beautiful, and that's because we're doing real data, so real data is not always beautiful. We then take the natural log of both sides. ln e to the minus 3b equals ln 39 on 299. That power drops out the front, so minus 3b equals minus 3b, ln e equals ln 39 over 299. ln e is just 1, so minus 3b equals ln 39 over 299. b equals ln 39 over 299 divided by minus 3. Now, that is not particularly pretty, but if we put it in our calculator, and I did it earlier, it comes out to be 0.67896. And that's the figure we'll use for B. The more decimals you can get, the better, but there's it. So what this means is our logistic function, FB, is equal to 1200 over 1 plus 299 e to the minus 0.67896 t. Now, that's pretty tough to visualize, so I drew it up on the calculator. It's here, 1200 equals 1 plus 999 etc. Make sure you put in brackets, and you can draw it. And you get the curve. So that logistic curve is pretty nice. A way to check if this is correct is G-solve. How many of you guys have used ycal?
Yeah.
Is that a thing? Cool.
Is it?
All right, what that means is I want to calculate a y value for a given x value. I can check my answer here by typing in 3. If I say the x value is 3, what should my y value be? If
30.
my model's, yeah, nice. If my model's right, it should be 30. And to all
not
intents and
perfect.
purposes, that is 30. It's
Oh, it's
close. The reason it's not perfect is because I've rounded to decimals. All right, so the original question is, where are we going to be in 7 days if our model is correct? Well, we're going to go G-solve across ycal and enter 7. And the model says 335.2. So approximately 335 people will have it after 7 days. And you can keep plugging in numbers. Eventually what's going to happen is you're going to plug in a high number, say 20 days later. And essentially everybody will have had it. It's where the graph asymptotes off at. So,
Mr. Gutenberg,
yeah,
but like this kind of function is just like predicting, right? Because
Yeah.
like it assumes too many things.
yeah. So in terms of predictive value, it has only a pretty limited application. Certainly not applicable to us, but it's an interesting sort of an example.
So like something
Where-
like this would have been done like for the COVID-19 pandemic.
Yeah. So we do model virus growth using this, but clearly they factor in far more examples, etc. Where we could reasonably use this would be, you guys know what a Petri dish is? Have you seen them in biology?
Yeah.
Yeah, or if Ivan leaves his sandwich on a table for a while, what'll happen is there's a little bit of mold at the start, and that little mold might double and double and double, and it'll start growing and growing, and over time it will fill the entire Petri dish. But towards the end, there won't be a huge amount of growth because there's not much more space to be taken up. So something where growth is extremely predictable, like in a lab, the logistic function works gloriously. In real life, less gloriously, but it's still a very useful function.
Will we expect something like this in the test?
Yeah, I'd be expecting one of these. On Canvas, I put 3 questions up that involve either logistic or surge. May have already done a couple of them, and I'll find you guys some more practice sort of surge type questions. But fundamentally, all that you know about calculus still applies. If you differentiate them and set the first derivative to 0, you'll find the turning point. If you find set the second derivative to 0, you'll find the inflection point. You'll be able to use a calculator with this. So if I ask you to find what the population is after 12 days, you can plug in xt equals 12 and it will tell you. I just thought it was worth a little bit of time online, talking about these 2 sort of examples of special functions.
So really the hardest part is just finding the values of A and B.
Yeah, I do think that's the hardest. Once you've got the A and B, then it turns into more of a year 11 sort of modeling problem where you're using your calculator. All right, so, and what did I say in announcement? What I'd love you guys to do now is to go and do those 3 questions ideally in that order. You may have already done them. If you're done with them, then do that this graphing booklet, drawing derivatives. I did all the answers last night on a video. If you're done with that, go on to the other exam booklet that we've done.
Are those
if
questions
you-
from the textbook?
Yeah, they are.
Cool.
Sorry, I'll just post them in the chat. And then does anybody feel like they're in danger of running out of maths to do or need more practice with stuff? Because if you do, there is last year's practice test to have a There's last year's practice test to have a go at. And I've put in some quadratics in disguise along with their solutions.
Oh, that's goated chocolate, Ivan.
Oh, 90%,
90%.
strong stuff.
It's pretty unfortunate. Like after every time when I eat dark chocolate, my stomach will bloat.
Well, give it to me.
No.
My stomach's so bloated already, it doesn't. No. All right. So if you have no questions and you all have work to do, set off. Otherwise, if you have a question, I know at least one person does, they can, by all means, stay on the call.
Yay. So like, I mean, the what was the first thing? The surge function.
Mhm.
It's like describing something in our body, like our body absorbs something, and then it goes a really high concentration, and then like over time it just decrease again,
Yeah.
like to
So
a
when
normal
you-
standard, like blood sugar, alcohol, drugs.
Yeah. Or when you eat that chocolate, the caffeine in it will hit you quite hard quite early, and then your body will break it down over time.
Chocolate has a ton of caffeine in it, Ivan. Well, not a ton, but it's got caffeine in it. That's why a lot of espressos taste like chocolate.
Do they?
Yeah, well, it depends where you source your bean from and like what grind and stuff. But yes, that's pod coffee. That's a different. That's a sadder game. So that's a different ballpark.
The school only has that.
That's out of my field of expertise.
Oh my god.
I have a quick question for surge functions. Is
Mhm.
the process for finding A and B the same as for logistic
Yeah.
functions?
Yeah, still math.
Yes. So the basic principle is if you have two unknowns, and in that equation there are only two unknowns, the A and the B, I should be able to give you 2 points on the graph and you solve simultaneously for them.
Okay, so it could be like when 1 hour has occurred, this level of drug is in the body, and when 0 hours occur, like when 5 minutes or whatever. Yeah.
Yes. Yeah. Absolutely.
Yeah.
Yeah. So it does. You guys can probably feel where this is going. It lends itself towards a simultaneous equations question, and then follow up modeling questions like using this information then.
Question about 3G.
Yes.
There was one question that you missed in the video
Oh,
that is bothering me because it's still a question mark in my book.
fair. What did I miss?
It was 12D. It was about how the seating one in the oval.
Oh, yes. Given the area of the ellipse is pi AB, what percentage of the ground is occupied by the seats in the optimal case? Oh, okay. Were you able to find the area of the seating?
I
optimal case?
found the local max.
Yeah, which is x equals,
A on root 2.
yeah, lovely.
But I didn't really know where to go from there.
Okay, hang on, I'll just dump it on my screen somewhere.
Oh my god, I'm sideways.
You are
How to spell alcohol?
AL
AL
ALCHO.
No.
ALCO.
HOL.
What she said.
Wait, hold on.
ALC.
No, I can just write Chinese.
ALCOHO.
Okay, 酒精. Okay, that's it. Alcohol. Oh, I forgot. I forgot how to write Chinese. Oh shit.
I can't help you with that one.
No one can help me.
12D, Olivia.
Yeah.
All right. So what we want to do is substitute this into there, effectively, and that will give us the area of the seating in terms of A. Is that it? Yeah, in terms of A and B.
And then do I have to do anything with the ellipse? being pi A?
You will do, because you'll need to find a percentage.
Okay.
So, well, we might as well do it. Area at the max, so A on root 2 is going to equal to 4B A on root 2 over A by the square root of A squared minus A on root 2 squared. All right. That's not particularly pretty, so I will tidy. That A and that A are going to cancel. And it'll leave 4B on root 2 at the front. And then we've got square root A squared take A squared on 4.
Mm-hmm.
I think we can probably still do more with that. 4B on root 2. Are you happy that A squared take A squared on 4 is really 3A squared on 4?
Yeah.
So that then is, that is then the square root of, it's just, and it's the square root of 3A squared on 4, which is root 3A on 2.
Yeah.
And if we multiply that together, what do we have? Like, oh, it's not pretty, is it? 4AB root 3 over 2 root 2. And then what we can do is cancel out the 4 and the 2. Give us 2AB root 3 on root 2.
Yeah.
We can probably go a little further. I reckon 2 is root 2 by root 2. So then we can cancel the root 2 on the bottom, and that then leaves us with root 2 AB root 3, which is AB root 6.
Yeah.
All right, so we've done all this battle to get that, and that, remember, is the area of the seats.
Yeah.
All right, area of the seats. The area of the entire ellipse is pi AB. All right. So area of, what is it, arena? Equals pi AB. And I guess they're asked for this as a percentage. So what percentage is filled? Because the numbers are scary. Let's say, I'll just make it much easier and then we can follow the same process. Let's say that the arena was 10 big and 7 of it was seats. What percentage full would it be of seats?
So the arena's 10 and then the area of the seats is like 7.
Yeah. It'd be 70%, right?
Yeah.
So what you're doing is 7 on 10 times 100.
Yeah.
All right, let's do that. But
you just do that with that.
Yeah, so we have AB root 6 over AB pi times 100.
Yeah.
Which actually works out gloriously because the A's and B's go and you're left with root 6 on pi times 100. Which I have no idea what that is. So we reach for a calculator. Root 6 divided by pi times 100. Oh, it's like 78%. or 77.96.
Yep.
Which seems reasonable.
Yeah. All right. Cool.
I have a question.
Oh, you do? Okay.
Yeah. Wait, sorry. That just sounded so, I don't know. I just hated that. Okay, so let me just turn myself the right way because it's messing with my head. For question 12 of page 76, when it wants to find like the stationary points of inflection, and it's just a negative sine x and it doesn't give me any values, how do I find it if I set it to 0?
Let me just click it onto my screen. All right, this one.
Mm-hmm.
All right, so that, wait, you've done A, right?
Yeah.
What does this location tell us about the inflection points? All right.
Oh no, I did that as well. I don't.
Okay, find and classify all inflection points. All right, so the inflection points occur when the second derivative is equal to 0. Yeah.
Yeah.
So we already basically told
Which
the derivative is just
is-
negative in the first one. So you're looking for minus cos x is equal to 0.
Yeah.
All
I
right.
don't know how to find x because I don't have a value for like. I just feel like x would equal 0 because
Yeah.
I don't know what to solve for.
Do you remember the unit circle? This thing?
Yes, I remember that thing.
Lovely. You have a theta here.
Mm-hmm.
This height is sine x. So we're not interested in it. This length, though, is cos x.
And that's a right angle triangle.
It is a right angle triangle. But the question is, when is that cos x equal to 0? And basically, theta swings around like this, going round, going round, going round. And you can see how that horizontal distance keeps getting smaller.
Mm-hmm.
When theta equals pi on 2, it's up here and the horizontal distance is 0.
Right.
So basically, cos of pi on 2 equals 0. So one of your solutions is pi on 2. The other solution
What happened to the negative at the front?
comes when the theta goes down here, is here at 3 pi on 2.
So x would equal pi on 2 or 3 pi on 2.
Yeah, and they are your two solutions in the first one, in the first rotation between 0 and 2 pi.
So you would recommend having a unit circle on my cheat sheet?
Yeah, so I'm not sure if you see my 3G, but as I go through 3G, I basically drag this image down with me while doing 3G.
Okay, no, because I have my little like sheet of everything I need to do this week. Yeah.
Cool. On your cheat sheet, as you started, I would draw a unit circle with the key values of sine, cos, and tan as you go around for the first 2
Yeah.
pi.
Can I print like that good copy of it onto a cheat sheet?
No, technically cheat sheet is handwritten. Otherwise, people end up writing in tiny and then shrinking it down to tiny font and printing it out.
What if I sketched it with tracing paper?
Yeah, go for it.
Okay. Okay, cool. And then the only other thing that I'm struggling with other than like 3G, but I haven't had a chance to watch a video yet.
Yeah.
Is the question 8, 9, and 10 of 3D.1. And then 11. And then 12 and 13 and 14 should be fine with.
8, 9, these 3.
Yeah.
Cool. And 11.
Yeah, and 11.
And 12 and 13, 14.
No, they're fine because they're the new ones that you just taught us.
Yeah. Well, I didn't teach you those bits, but it's the same algebra stuff. What was I thinking? All right, so 11. No, 8. All right. Have you found the x-intercept?
I don't know. This is a long time ago.
Fair.
Question 8. Yes. No.
No?
I gave up.
All right, let's find the x-intercept. So the x-intercept happens when f of x is 0. So you've really got 0 equals ln 2x take 1 minus 3.
Yeah.
Add 3 to both sides. 3 equals ln of 2x take 1. I would then raise both sides to the power of e. So e to the 3 equals e to the ln 2x take 1. Which doesn't seem particularly pretty, but then e to the 3 equals 2x take 1.
Because e to the power of 0.
Yeah. Kind of cancels. They're inverse functions. They undo each other. Add 1 divided by 2. X equals e to the 3 plus 1 on 2.
Yeah.
And that's your answer.
Okay.
Can f of 0 be found? No. Basically, because if you put 0 in there, it is undefined, meaning
It's negative and it has to be greater than 0.
Yeah, you can't log a negative. So what's the significance of this result? This means that actually when x is 0, it's undefined. Yeah. Find the domain of f. So the domain is the possible set of x values.
Yeah.
Here x must be greater than or equal to a half.
Yep.
You happy with that from the bit in here?
Then a half.
Yeah. Because
okay,
2x minus 1 must be greater than or equal to 0.
Yep. And so 0 is equal to x is equal to a half. Yep. Beautiful.
A half.
Yep.
Find the gradient of the tangent of the curve at x equals 1. All right, so gradient of the tangent of the curve, we just need to find f dash, basically f dash 1. So f dash x.
Yeah, that's fine.
Is 1 over, well, it's 2 times 1 over 2x take 1, which is just 2 over 2x take 1. If we sub in 1, it's 2 over 1, which, yeah, the slope should be 2. Yeah. Find f double dash x, hence explain why it is concave downwards for all. All right, f double dash x means that we need to take this and derive it again. Yeah.
What happened when you derived f dash x? What happened to the negative 3? No, it's a constant. Never mind. I'm stupid.
Yeah, it's constant, so it just goes.
Sorry,
I would think of this as 2x take 1 to the minus 1.
Yeah.
Because then you don't have to use quotient rule, you can use chain rule to derive it. So when you derive it, it'll be minus 2 bracket 2x take 1 to the minus 2, which equals minus 2 over 2x take 1 squared. So explain why it is concave down. All right, the reason it is concave down is because the denominator will always be positive. You see, no matter what x is, it's squared, it'll become positive.
Yeah.
You're always going to have this minus 2 divided by a positive number. And when minus 2 is divided by a positive number, you're going to get a negative number. What that means is that no matter what value of x, f double dash x is always going to be negative for all values of x. You'll have to write down something more fancy, but that's the crux of the explanation, is that the denominator will always be positive and therefore the second derivative will always be negative.
Okay.
Graph the function.
Okay, just plug it into calculator.
Yeah.
Too easy. Thank you. That should help me with all the others.
Nice one. Yeah, it might have been the raising both sides of the e that was the tricky thing.
Yeah, I didn't know how to get rid of the ln.
Yeah, fair.
Okay, cool. Thank you.
Easy.
Good afternoon.
You too. Hey, Lala.
Hi. I have lots of questions, as you know.
All good, yep. Thank you for being patient.
No, it's okay.
Where would you like to start on your questions?
I have two from 3B, so from a while ago.
Yeah.
We just might as well start from there.
Sure.
I did, like, with those ones, I've done most of, like, the working out, but I think I've just gotten stuck somewhere and I haven't been able to figure out what I've done wrong.
Yeah, which questions from 3B was it?
Questions 6 and 7A.
Cool. Let's have a shot at 6. Just let me dump it on my screen.
Mhm.
And share screen. All right, so consider this, show that, and draw its Sine diagram.
Mhm.
Oh joy. All right, so we're thinking quotient rule.
Yeah.
Where u is minus x squared plus 4x takes 7.
Mhm.
U dash is then minus 2x plus 4.
Yeah.
And v is x take 1. V dash is 1.
Yeah.
All right, then f dash x is going to be u dash v. So minus 2x plus 4, bracket, bracket, x take 1.
Mhm.
Yeah. Minus v dash u. Minus x squared plus 4x take 7.
Yeah.
Over x take 1 squared.
Mhm.
All right, now we can see where it says show that there's an x take 1 squared on the bottom, x take 1 squared on the bottom. So we're happy with the bottom. It's just a matter of fixing up the top, right?
Mhm.
All right, so in order to fix the top, I'm going to expand that out. Expanding that out will give me minus 2x squared plus 2x plus 4x minus 4.
Mhm.
And I'm going to distribute this negative into that bracket
Yeah.
to make plus x squared minus 4x plus 7.
Mhm.
And all of that is still over x take 1 squared. All right, now let's collect like terms. There is a pair of x squares, which just leave me with minus x squared. Then there is 3 lots of x, but they all collect together to just make plus 2x. Yeah.
Mhm.
And then there is a minus 4 and a plus 7, which gives me a plus 3. Over x take 1 squared. At this point, you see how their solution has a little negative at the front?
Yeah.
I think that is a good sign for us to factor out minus 1.
Yeah.
X squared minus 2x minus 3 over x take 1 squared.
Yeah.
Then drag your mind back to year 9 or so. Remember sum and product?
Yeah.
We're going to factorize that bit inside the brackets with sum and product. So minus 1 bracket, and then what numbers multiply to -3 and add to -2?
Positive 1 and negative 3.
Good. X take 1, x take 3 over x minus 1 all squared. Which should be it. Yeah.
Mhm.
Nice. All right. So we've shown that successfully. And draw its Sine diagram. All right. Sine diagram.
This is the part where I got stuck because in the answers they have 3
Yeah.
Numbers, they have like an asymptote or something in the middle.
They do. Sorry, I could have just skipped straight to here if you said you knew how to do this bit. All right, sorry. Sine diagram. Basically, sine diagrams need two key pieces of information on them. They need the zeros, so when this thing is going to equal to 0, which is -1 and +3. Are you happy? And they come from the top.
Yeah.
From the bottom, though, when the bottom equals 0, and I know it can't, but if it did equal 0, it will be undefined. And as it gets very, very close to 0, the sign can go up a very, very long way or down a very, very long way. Have I done a thing where I draw a table of values out to show why that happens?
I don't know.
All right, I'll just do it quickly now. Consider the graph of y equals 3 on x. And we'll do a rather ridiculous table of values with x and y being -3, -2, -1, -0.5, -0.1, -0.11, or 0.01, 0, 0.01, 0.1, 1/2, 1, 2. All right. I know this looks like crazy, but if we substitute in that x, these x values into there, 3 divided by -3 is -1. 3 divided by -2 is -3 on 2. 3 divided by -1 is -3, -6, -30, -300. What's happening is, as we get very close to that 0, it goes towards -infinity as we're getting close to 0. It can't actually equal 0 because you can't divide by 0. And then something interesting happens when we go the other side. 3 divided by 0.01 is 300 positive. All of a sudden we're back up here and the graph does this. So in terms of slope, there's a fairly massive sign change. It goes from negative to, well, the slope's still negative, but we're changing either side of that. It's going from negative and then it jumps up here and stays negative going down. But you can have cases where it does this. Have you seen those photographs where it goes from positive to negative across an asymptote like that? And that's why we need to consider the denominator as well. And the denominator gives us an asymptote, which they mark with a dashed line, and x equals 1.
So how do you know when to do, like when there would be an asymptote?
You'll get an asymptote anytime you're dividing by something that could potentially be a 0. So here it will be 0 when x is equal to 1. But if you had like, if someone was particularly nasty, put a sine x on the bottom of a fraction. Sine x equals to 0 at 0 and pi, and 0 and 3 pi and 4 pi. Every time you hit 0 on the bottom, there'll be another asymptote shooting up.
Okay.
Understand how to get these signs in between, the pluses and minuses?
I think I just want to go through it again just to
sure. Wait, you want me to go through it?
Yes, please.
Yeah, okay. So basically we're going to pick values that fall in between these key values and substitute them into this equation. So, yeah, Patrick. I would, well, let's do this one here. I would sub in a number between -1 and 1. I'd sub in 0. And while you're subbing it in, I would just put a sign above each of these brackets. If I subbed in 0, that one will be positive because it's 0 plus 1. This one will be negative, and that one will be positive because the square will makes it positive. Also, there's a -1 at the front. Yeah. Now, without actually doing any calculations, I can tell you on the top there's a negative number multiplied by a positive multiplied by a negative. So the top's going to be positive, bottom will be positive. Therefore, in here, goes a big plus sign.
Do you always substitute it into the derivative, like the f of x? Because I think sometimes we've done it the other way. You've subbed it into the original function.
Yeah, good question. So let's say I wanted to find a local maximum. You see how -1, I would sub -1 into the original function to find the location of the maximum.
Oh, okay.
So like it would be therefore -1 comma some value, which would be f of -1. But that wouldn't.
But besides that.
Yeah. So if I want to sub in values either side, I go into the derivative because that tells me the slope. So the slope here is positive.
Yeah.
If I sub in, say, the number -2, -2 is going to make that negative. That's still negative. That's positive. There are 3 negatives on top and 1 on the bottom, 1 plus on the bottom. It'll make that minus.
Okay.
Actually, -1 is going to be a minimum because it's like negative and then positive. And then if I choose a value between 1 and 3, I could sub in, say, the number 2. If I sub in the number 2, that would be positive. Negative, negative, it's going to be positive. And then if I sub in another greater than 3, like 4, that will be positive. That's still positive. It's going to be negative. And then I think the next question asks state periods where it is increasing. Is that right?
Increasing or decreasing, yeah.
Okay, so you would just state the values of x which is decreasing are these ones, and it is increasing in between here.
Yeah, that makes sense.
Cool.
Okay, cool. With the next one, I got up to the same point. I got up to the Sine diagram, and then I got confused with 7a.
Okay.
Because I got x equals 0, x equals plus minus the square root of 3, but I'm not sure. What did the answer say? I just looked at the answer to me.
So what was your derivative?
I got x squared times bracket x squared take 3 over x squared take 1, and then the whole thing squared, which is
cool.
Yeah.
All right. So your Sine diagram would have been 0, an asymptote at 1.
That's probably where I got confused again, is the asymptotes. I didn't realize.
Oh yes, the asymptote at 1 is coming from the bottom here.
Oh, and there would be a -1 as well because
yeah,
it's
good.
plus minus. Yeah.
Yeah, well done.
Okay. Yeah, that makes sense.
So there's 2 asymptotes, and there's a normal cut at 0 and another normal cut at plus or minus √3.
Yeah.
So plus √3 and minus √3. And then you have to do the laborious process of substituting in values here, trying to figure out if they're negative or positive.
Okay. Cool, that makes sense. The next one is from 3. Oh, is it from 3? Yeah, 3C. It was question 6, I think. Yeah, question 6.
All right, question 6 is this one here.
Just for B.
Okay, show the minimum value. All right, so you'd have done the derivative. What was your f dash x?
Oh, I didn't know what to do for that yet.
Oh, okay, sorry. I would use product rule, where u is x and v is ln x. Therefore, u dash is 1 and v dash is 1 on x.
Yeah.
So the first derivative, we then do u dash v, which is ln x, plus v dash u, which is really just going to be x on x. Because that's those guys multiplied together is x on x, and that's just going to be 1.
Mhm.
So therefore, f dash x is ln x plus 1. And we want to find a turning point, so we're going to set it equal to 0.
Mhm.
Minus 1 equals ln x. To solve for x here, we raise both sides to the e. So e to the minus 1 equals e to the ln x.
Mhm.
E to the minus 1 equals x. Oh, sorry. No, I'm not sorry.
Mm.
Yeah, I am.
Isn't that right? Because then
It's not. It's because that's going to be x equals
Oh,
1 on e,
1 on e, not negative.
not negative. So where did the
Mm.
negative go?
Um. mm, Sorry.
Yeah. I don't think it is a negative. I think they made a mistake.
Oh.
You see how x
Oh.
ln x has a minimum there,
Yeah.
which is a positive number.
Mm-hmm.
I reckon that's just. Oh, I know what it is. Sorry, we're right. This is good.
Mm-hmm.
But now we need to find the location of it, the minimum value of. So we need to substitute this into the equation. So then we sub it into y equals x ln x, and we go 1 on e ln 1 on e.
Mm-hmm.
And the natural log of 1 on e is -1.
Mm-hmm.
-1. So therefore that is -1 on e,
Right. Okay.
which is the minimum value.
Mm-hmm.
It occurs at a positive x value, but there's a negative y value.
Mm-hmm. Okay, cool. And the other one from 3C is 7A as well.
Wrong book. All right. Determine the position and nature of the stationary points in interval 0 to 2π, then show them on the graph. All right, so stationary points occur when f dash x equals 0.
Mm-hmm.
So we need to find f dash x for a start. In our case here, f dash x is just cos x.
Yeah.
Sine derives the cos. So we're really looking for where 0 equals to cos x.
Mm-hmm.
And for this, we'll need a unit circle. So unit circle is certainly something that should be on your sort of cheat sheet.
Mm-hmm.
But you might remember that for a unit circle of theta, okay, my theta drawing skills on the screen are not good. Theta. This portion here is cos x, and the vertical is sine x.
Mm-hmm.
And basically, theta swings around like there, until here at this point, which is pi on 2. There's no horizontal component. So cos of pi on 2 equals 0. And that happens a second time around here. Down here at 3 pi on 2, it's also equal to 0.
Yeah.
So your Sine diagram would look something like this. You're only told to consider between 0 and 2 pi. So you're going to have a pi on 2 and a 3 pi on 2.
Mhm.
And then you will need to figure out the signs in between them.
Mhm.
I would probably substitute in 0, it falls down here. Cos of 0 is positive 1.
Mhm.
That's positive, and your calculator can help here. I would sub in pi. Pi falls between half pi and 3 halves of pi. Cos of pi is -1.
Mhm.
And then I would sub in right to the other extreme, 2 pi. Cos of 2 pi is positive 1.
Yeah.
And therefore you will have a maximum at pi on 2 and a minimum at 3 pi on 2.
Okay. Perfect. So then I just put like pi on 2 back into the original function and then put it on a graph or whatever.
Yeah, nice. So if the original function was sine, right?
Mhm.
So if you do sine pi on 2, it's going to give you 1, which will be a max. And if you do sine of 3 pi on 2, it'll be -1, which is a min. Hi, Isaac. Yeah, come in, grab a seat. How have we gone through your questions? We probably haven't done them all, have we?
No,
No.
sorry. If you want, I can just like do it another time if that's easier.
Yeah, we have a double lesson tomorrow. Can we pick it up again then? I'm sorry, I've just got
Yeah,
students
that's
come to
fine.
see me and then I've got meetings.
No, that's okay. This will help, and I can do the stuff we've like been doing yesterday and stuff.
Yeah, okay, nice one.
Okay. Thank you for your help, though. That was much better. I feel a bit more confident about it now.
My pleasure, yeah. So do have a shot at the rest of the ones in those sections.
Mhm. Okay. Thank you.
Pleasure. Yeah.
Bye-bye.
All right.
Mr. Bloomberg,
Connie, hello. You've been very quick.
I need help with
Which one?
the 3D.2, 13 and 14.
3D.2. Aren't they the surge and logistic ones?
Yeah, they're the surge ones.
Let me just share my screen. Not that. Share. All right. Prove that the function has a local maximum. Did you differentiate using the product rule?
Oh, sorry.
Did you differentiate it using the product rule?
I did, but I don't think I did it right.
Did you use u as at and v as e to the minus bt?
Yes.
Cool, you probably did it right. Then u dash was just a, and v dash was what, minus b e to the minus bt?
Mm-hmm.
Cool. And then you
Oh,
did.
but then you have to do. Oh, that's what I did wrong. I didn't write it out right.
Oh. My feeling is once you wrote it out, you should have been able to factorize e to the minus bt out. And probably an a out as well. I'll just do it. Or are you doing it?
Minus bt. And then 1 minus. Yeah, you get 0. Okay.
Is that
I see what I
happy?
did wrong there.
Cool.
and then you double differentiate it.
Yes.
That,
and a
and
very
then you
similar
sketch
thing
it.
will happen. Yes.
Okay, that's all.
Okay, awesome.
Thank you.
I will see you tomorrow then.
Yes. Bye bye.
All right, bye.